Welcome to the CBI laboratory. This is where we produce the Supacem cement. This place is the heart of the plants. Whatever that we do here reflects in the plants and then in our products as well. So I'll give you a tour of what we do here and then you'd ask me any questions that you have.
I have a lot of questions for you.
Sure, I'll be willing to answer them all for you. Over here in the CBI laboratory, we have 4 laboratories actually.
Okay.
We have the physical laboratory, chemical laboratory, the process lab, and then the concrete lab.
So this room where we find ourselves is which one?
This is the physical laboratory.
So what happens here?
All the physical tests on the cement or on the raw materials, this is where it happens.
So if you say physical test, what is
Physical as in compressive strength test, setting time test, expansion test, and all others, those kind of physical things. Yes, that's what happens in here. In the chemical lab, we do chemical tests, so that's where we add reagents and other stuff to the cement, looking at some chemical reactions and all that.
So I'm assuming that everybody I'm seeing here is like an engineer or has like a background in...
We are all engineers here. Okay. Yes, wow. We have chemical engineers here, geological engineers, we have industrial chemists in our midst.
Wow. Yourself, tell me about your profile.
Okay, I'm a geological engineer.
Okay.
I did geological engineering in school. And then after school, I moved into the building and construction industry. And because of my background in geological engineering, I specialized mostly in the building materials, the geological materials that I used in building. That's how I found myself in cement and then in concrete. So I've been doing concrete tests, cement analysis, formulating recipes, and the whole lot. What she's doing here is the compressive strength test. This is one of the most important tests on cement. So you know, for Supacem, it is 42.5 R.
People are asking, what is 42.5 R? And how do you ascertain that this is 42.5 R?
We use the compressive strength to ascertain the 42.5. Compressive strength is the minimum stress that can break your sample at 28 days. For the 42.5, that's the minimum strength that our cement is supposed to have at 28 days. It's supposed to be 42.5 MPa.
Now, explain it as if I'm a 10-year-old.
Our standard for cement, we have the 32 and then 42, depending on what it's going to be used for. The international standard dictates that at 28 days, when we mix cement with standard sand and then water at specific amounts and then crush it, we are supposed to get this value, that minimum value. So that minimum value is the 42.5.
So the 42.5 we've been seeing on the Supacem bag, it means that after 28 days, if you mix it with standard sand and then you crush it, that's the strength you are supposed to get.
Exactly.
Now, how does that apply to a building that I'm putting somewhere at East Legon Hills?
For our building, there are specifications for the concrete or for the blocks that we do. There are specification strengths for them. And these 42 or the 32 helps in giving or producing that specifications. Okay. Let's say a building. In your building design, the architects could write that you should use a C30 concrete. C30 means that at 28 days, the concrete strength should be 30 MPa. Okay. So the C30 concrete, you need to use this cement to do it, 42.5 to do it. So in the 42.5, depending on the engineer's discretion and then the materials that he will use, he has an amount of cement that he would add to the mix.
The mix ratios come to play. Exactly. So it's not just using the 42.5, but the mix ratio. In
order to have a good mix ratio, you need to know the strength of the cement. You cannot use a mix ratio like formulated specifically for 42. Then you'll be using a 32 cement. You're going to have a lower outcome at the end of the day. And then even if it's a higher form, which we don't have in Ghana. So if you use that same amount of cement with that specific mix ratio, you're going to have a higher strength at the end of the 28 days, which is not the specification given to you by architects. Every part of the building has its specifications.
So if I don't adhere to the specifications, the mix ratios, and the 42.5 Supacem, what's the impact on my building? Is it that I'm going to see cracks, or the durability or the structural integrity of the building is going to be compromised?
Yes, everything that is mentioned, the durability, structural integrity, everything is going to be compromised because you've been given a fixed specification, fixed amount that you need to use, and you have decided decided to reduce it just to save money. You know that you are not going to have a good building at the end of the day. Take an example, you are doing gari soakings. Okay, you have some gari, you have sugar, and then your granules and stuff. But you find that, oh, sugar is expensive, let me just reduce the amount of sugar and then take more gari. Now it won't be sweet as if you had more.
Is that all that happens here, the compressive strength?
No, that's not all that happens. We do certain time test as well. When I say certain time, it's the time with which the cement dries, the period in which the cement will be workable before it dries. That's a certain time.
Why is that important to somebody building their house at Kaswa?
Imagine you're building your house at Kaswa and you want to use a ready-mix concrete company. And that company, you think that's the best company you can get. You don't want anyone around Kaswa. And that ready-mix concrete company is around the mall area. They have to bring concrete all the way from the mall to Kaswa. Now imagine if the concrete dries very fast. By the time it gets to Kaswa, your concrete will already start caking. And how would you pour it? By the time you are pouring, it's already caking. It wouldn't fill in the pores in the reinforcement bars well. You might have to add water, which will then decrease the strength, compromising on the structural integrity.
For Supacem, you are looking at quality, durable buildings.
Exactly.
Like no compromises in between. Wow.
Exactly, no compromises in between. This phase is actually the last stage in the compressive strength test. The compressive strength begins from the mixing stage. This is where it starts from. We have our samples here. So in a normal compressive strength test, in the EN 196 standard, we need 450 grams of cement, 1,350 grams of sand. And this sand is not just any sand, it's standardized sand. We have the particle size distribution fixed, and it's already bagged in 1,350 grams.
Everything is according to standard.
No compromise. And distilled water, 225 grams of distilled water. So we mix this in here, we pour everything in and then mix it. So he will mix it for us to see.
So this is what a beaker, or what's it called?
This is a measuring cylinder.
So when we look at it, we have to see that it is 225 grams.
Exactly. And to be even more sure, we weigh it in addition. So he will mix it for us to see.
What is this machine and what does it do?
So this machine is a 2-in-1 machine. It's used for the compressive strength and then the setting time test. It basically mixes the cement with water or with sand.
Does it mean that when we are building, we need to use this type of sand or?
No, you don't need to use this type. This sand is very expensive.
You are using it for your quality assurance process?
Exactly, for the quality assurance process to ensure that we have our 42.5 as stated on the bags. But then when you are doing your building, that's what I'm saying, depending on the engineer's discretion or the materials that he's using, he would now formulate his mix ratio depending on his materials. But he needs to know the strength of the cements that he's using. The same way, he needs to know the kind of aggregates that he's using, whether more of fine aggregates or more of coarse aggregates. He needs to know the slump that he requires. As you can see now, we are done with the mixing. He will now put it in this mold, and then this machine will compact it, like how the block makers compact their blocks. So after that, it will then be allowed to dry, and then after 24 hours, we'll now demold it.
If somebody wants to lay blocks, there's a 42.5 Supacem good.
Yes, it's a very good option for blocks. With the blocks, you need very minimal amounts of water because it's made with a lot more sand and then it has to be vibrated for a while. So with the 42.5 cement, after doing it for about a few days, you can now have your very dry blocks, which wouldn't be crumbling or be very weak.
42.5 Supacem is also really good for block making.
Yes, it's very good for block making. Very good.
So that's a compacting process?
Yes, it's a compacting process. So what we have here is the humidity chamber. Now after our compaction on the jolting table, the mold and then the sample is brought in here and made to dry or set for 24 hours. Now the reason why we use the humidity chamber is to have standard conditions of temperature and humidity.
Humidity, okay. So this is what, STH?
Yes. standard temperature, and then humidity. So the standard temperature needed is 20 degrees Celsius plus or minus 1, so 19 to 21 degrees Celsius. That's the standard temperature. And then the humidity shouldn't be less than 90%. Of course, with cement, if you put it around, it will dry, but it won't dry under standard temperature and then humidity. That's why it's kept in here.
But Ghana is our standard temperature 19 to 21.
That's why you need a humidity chamber.
For Supacem 42.5R, what are the ideal conditions for storing it to ensure it lasts, and how long can it last?
Yes, so the ideal condition is one, the temperature. We need to store it under a cool temperature. So 20 to about 23 degrees, that's okay. And then cool humidity. We know that there is heat, usually during the daytime, and then at night time because of the heat in the daytime, there is some kind of frosting or dew. You have to keep it at a dry place. And then one other thing too, is not supposed to be put on the bare floor. Tile is even worse. Yes. Okay. So the best thing that is needed is a pallet, a wooden pallet. Okay. Yes, so it needs to be kept on a wooden pallet. That's the best. That's because with the tiled or with the bare floor, it usually gets cool.
But how long does cement typically last?
Cement typically lasts for about 6 months. After 6 months, the strength begins to dwindle. This test that you are doing is the setting time test. The setting time is how fast the cement dries. You might need to work with the cement for a long time. You might need to transport it to a further place. We need to know the time range in which our concrete or our cement will be workable.
You mentioned that cement is able to last for about 6 months. That 6 months, is it from when you guys produce it at the Supacem factory, or it is when it is sent to the distributors?
It's when we produce it at the factory. Wow. On our bags, we have the production dates on the bag. That will help you know how long this cement has been in the store, or like how long it has been produced for. So you know the strength range we are expecting. With the compressive strength, we do concrete as well. And over here, we test the compressive strength for the concrete as well. There are specifications that your engineer would give you. Okay. And then these specifications are needed for your concrete recipes or for recipes or the kind of mixes that you do for your blocks. So in here, we know that mostly that the cement is used for concrete. So we do our own recipe in here and also crashes to see if our standard is up to what they want to also achieve. And then whatever issues they might have whilst using our cement. Maybe issues like maybe addition of more water, because there are specific proportions that you need to use. If you add in more water, we are going to mess up with the proportion. Okay, and the strength will be affected. Okay. The reason why compressive strength is very important is that without the compressive strength of the cement, you wouldn't know the right ratios to mix in order to get to your required specification of concrete that you need to use. In the concrete world, there are different classes that they also need. There's a C30, C40, C25, depending on the exact thing that the concrete is going to be used for. For something like columns and slabs, the standard that usually used in Ghana is around C30, which means that it should be 30 MPa at 28 days. And there are some that you might need a lower MPa, like 25. There are some that you might need higher. How would you know the right proportion of cement to add to the other materials? Yeah. So that's why we always need that 42.5 grade to know the kind of proportions that we need to make for our required class of concrete. From
working in materials and cement and all these things, how important do you think that people should not skip any of the processes?
Yes, it's very important not to skip any of the processes, because you cannot give your building, your lifetime investment to chance. Okay, just because you need a place to live or you need to be very quick and then build it. You can't give it to chance. Maybe getting a professional to give you the right design is not what you cannot afford. You can read a lot or read more about these kind of things, these 42 MPa cements that you need, or the classes of concrete that you need for your design, or even research on the appropriate proportions that you need. Okay, you can do that on your own, so that when you are working with your masons, you tell them, no, I want it this way, I want it that way, because that's what I've read, or that's what I found out on this website or online.
On this video, sponsored by Supacem.
This is what I read that is the best. So you can just read around these things. Okay, just ensure that you are doing the right thing, not just leaving everything to chance.
So currently, what is happening?
So we have our concrete in there that is being crushed. Our concrete is a mix of cement, sand, and then chippings, and then water. We have an in-house recipe that we use. So as I said earlier, you can't leave anything to chance, but then if you buy Supacem cement and tell us, oh, I don't really have any recipe in mind, can you give us a good recipe? We are willing to give you that kind of recipe. So we work with this recipe on our cement to ensure that our cement that we are sending out is good. And anytime there is a change in any of the materials that we are using, we are able to see it in the strengths here, because it will affect it one way or the other.
What is going to be the impact of using salt water for your mortar, concrete, etc.?
The one thing that we fail to realize is that cement is a chemical substance. It reacts with the water in order to bind it. The introduction of other materials in there gives it another chemical reaction. Now you are introducing salty water, which means there is salt in there. So there's going to be another reaction that's going to be formed inside. And then the cement, as it is after it's dried, because it's a chemical substance, there are some chemical reactions that goes on with the cement and then its environment. That's why after some time, okay, you can see buildings, there'll be like some pores. You have some like reactions going on in there because it's actually reacting with the environment. There is this kind of reaction that goes on a lot at the seashores. Usually at the seashores, when you have these concrete buildings and stuff, you can see that the sand is wearing off out of the chippings. The chippings are now exposing the cement and then the sand because of the chemical reaction that's happening between the salts in the environment and then the cement. Okay, so it's going to actually reduce the durability of the cement. Cement in its nature is supposed to increase in strength as time goes on. But this is a case with yours, the strength will either be decreasing